R looks like this. Okay, so it's very hard to use R like this because you have to run it using the command and using the packages. Okay, so you can see here R. They say you script, you open script, you play script, you so on and so forth. So this is tedious. Then you can see that some of these items require you to download things from elsewhere. What is packages? Packages is a list of commands that you can run to execute something. Okay, so you can run to execute something. So it is like an automated menu lah. So you select menu, I want to run logistic regression. You install package for logistic regression. So it is not like SPSS. So you have to type in the command yourself, or you have to copy and paste somebody else's command into your computer. So you can see here, if you go through the manuals and the function, you will see that it is very, very frightening. Okay, why frightening? Even simple manipulation, you have to type in the command. Okay? Even simple manipulation, you have to type in the command. And you have to type in even the data set, similar like SAS. Okay, so this is very, very frightening. For people like us who are manja dengan SPSS, it is quite hard for us to use R. So to overcome some of that problem, instead of using it directly from R, we are using RStudio. So RStudio is just the graphical user interface for the R. So it does not run the analysis themselves, but it runs the analysis through R software. Okay, so I'm going to show you today on how to use this RStudio. Can you see my RStudio screen?
Boleh, Prof.
Boleh, okay. Some of the guide on how to navigate around here. Okay, there are I think you can see 4 windows here. So windows here is 1, 2, 3, and 4. So this is 1, this 2, this 3, this 4. Somehow this one does not jalan. Okay, so you can see here control 1, control 2, control. So you can jump to all these screen. Okay, so this is how you shift from one view to the next. Okay, so you can see just now what I said just now. We have control for files control 5, for plots is control 6, for packages control 7, for environment is control 8. So each one of this window got all this control. So if you want to see the viewer, is control 9, for connections control F5, so on and so forth. So this all control shift ni. Control shift ni allows you to jump from screen to screen. Okay, control shift jump allows you to jump to from screen to screen. So right now we got 4 screen in front of you. Okay, so if you look here on the page, okay, control alternate shift 0 will allow you to see all the 4 screen. So control alternate shift 0 will allow you to see all the 4 screen. Control shift 1 is for the source, control shift 2 is for the console, so 3 for the help. Okay, so on and so forth. So the control shift is the button to navigate. Control shift is the button to navigate. So I try again, Sally. I try the ID. Control shift 1. Okay, it works. Control Shift 2, Control Shift 3, Control Shift 4, 5, 6, 7, 8, 9. Okay. Now if you want to see all the screen again, Control Shift Alternate 0. Now you see all the 4 screen at the same time. So that is how you navigate inside RStudio. Okay. That is how you navigate inside RStudio. So please take note, we don't run the software inside R itself. We run the software inside RStudio. RStudio, they got 2 packages. One is the commercial one, the other one is the free one. The commercial one is free. The commercial one is 995 US dollar. Okay, almost 5,000 ringgit. Okay, then you have the free one. Okay, first thing you have to take note, you have to create a new project. So please click File, New Project. Okay, we are going to create a new project in a brand new working directory. Okay, so you select New Project. Okay, name of the directory. Okay, class R class, R intro. Okay, R intro. Okay, so you just click create project. So you can also create this project as a subdirectory of another file. Okay, so create project. You will see that R environment with this project. This R environment is, if you're using packages, you have to allow this thing to work, because the R environment is a redirection file. So if you want to use packages, you have to make sure the R environment is on. Okay, so I'm not going to use packages, so I'm not going to use that. So I'm just going to click on new project and create a new session. Okay, so open a new session and create the project. Oops, you must I'm going to put inside my D drive. Hello D drive. Okay, okay, so create project. So now they created the new project. So as you can see now, you have this new project. Everything starts clean. Everything starts clean. The other one I'm not going to use. I'm going to start the clean one. Okay, so this is the clean one. As you can see, there is a physical folder here. Okay, there is a physical folder here. So I know you already downloaded the dataset. Please download the dataset and unzip the OS files into the R project, the intro project. Okay, so why? Because that is how it works. That is how it works. So now we have this dataset. Okay, I'm going to copy this OS and OS2 files. Copy. I am going to physically transfer it to the D drive. The D drive. Okay. So I have this folder R intro. Paste. Okay. Why we have to transfer it like that? See? Then the file is now inside the project file. So under R, you must work like this. Every project that you do must be inside their own folder. So you cannot do like SPSS. No? SPSS you put everywhere, it does not matter. You can still open. But under R, you must have a specific folder for the file. Okay. So now the first step we're going to do, we're going to create a dataset file inside R. R can support all format. R can support all format. But please take note, okay, please take note that where you import the R matters. Where you import the dataset into R matters. Where can you import it? You can import it from any of the 4 windows. You can import it from any of the 4 windows. You can import it from here. Okay. So you can, if you click here, you can import it from here. You can import also from here, up there. Import dataset. You can also import it from here. Okay. Import dataset from Excel. Okay. Or you can also import it directly from the command. So there are 4 ways of doing this. Okay. Because today is our first session, I do not want to scare you all off. We're going to import it from the left side. Import dataset from Excel. Okay. So browse OS. Okay. So you're all supposed to get the OS files. Click open. Okay. See this one? First row as names. Open data viewer. Name of the file is OS. Sheet is default sheet. Okay. So what is the command? The command is like this. Okay. Library, read Excel, OS, read Excel, in bracket, OS XLS. So the command that you're supposed to type inside there was this. Okay. You're supposed to type like this. Okay. But today we just take the shortcut. We just use the menu. But later on, you will have to use this command. Why you have to use this command? Because you're going to learn to save the script, each one of these, one by one, whenever you run analysis. That is the biggest difference of using R compared to SPSS. Okay, so you can see there, on the left side at the bottom, the command is there, library, read Excel. Okay. Why OS? OS is the name of the new dataset. Okay, so this is os.r. Everything in R, the file set is .r. Okay, so read Excel from where? From the file os.xls. Please take note of the brackets there. After that, you set the command to view the file here. Okay, view the OS. So you can see here, this file is from Ayub. There is 100 dataset, 100 entries. They have age of people. You can see there, so on and so forth. Okay, so you want to sort data, you can just press this button. So the youngest is 27. The oldest is 55. Gender is male and female. 1 is for male, 2 is for female. Ethnicity, you got 1, 2, 3, and 4. So 1 is Malay, 2 is Chinese, 3 is Indian, 4 is others. Education level, we got 1, 2, 3. Okay. So primary, secondary, tertiary. Income, the lowest is 400 ringgit. The highest is 10,000 ringgit. Okay. X time. Okay, if you see there 6, 7, whatever. Then you got obesity. Obesity is 1, 2 only. So it is yes and no. So 1 is for yes, 2 is for no. Again, smoking, same, 1 and 2 only. 1 is for yes, 2 is for no. Okay, so forth. So you got all these other data. Okay, so it does not mean anything to you now. But if you want to know what does it mean, you can check under the file that I gave you. So under the file that I gave you just now, you can see this is the data description. Obesity survey in district A. Okay, so these are everything about data set. Okay, so you have knowledge, attitudes. So there are 5 knowledge questions, there are 8 attitude questions, and we have the pre and post. Okay, so we have the duration of exercise. So this now was the duration of exercise. Okay, so that is the explanation about the data set. Okay, let's play around with the data set. So please take note, we already saved the data. Okay, so about the screen, now you see all 4 screen already. So here is the screen for the data set, but also anything is also displayed here. If you create a script file, the script file will also be here. Down here is the console, the command terminal. Okay, so remember the command is Control Shift to jump from screen to screen. The one on the right side is the environment. You're working with what environment? So the environment here is the data set. The name of the data set is OS. Okay, please take note. They tell you the name of the file. Okay, they tell you the name of the file. Okay, they have the data set in how many bytes. So it is 18,000 kilobytes. 18,000 bytes, so it's about 18K. You can save the file here. So whenever you're doing your work, you just save here. So you can set the name of the file, whichever. So right now, you just type the word intro, you just save. Okay. So there's a big difference. You don't save as SAV file or whatever file. They save as the whole environment. Okay. Whatever command that you type is there under history. The connection, if you already created the connection for them to update automatically, is there. Okay, one big difference in mine and yours, I got tutorial. I got tutorial. You all don't have tutorial. Never mind, if you want tutorial, you just click, automatically they will install for you. Down there in the files, beside that you have the plots. So whenever you run to create the plots, it comes there. If you already installed any of the packages, so these are all the packages. These are all the packages. Doctor, what the hell is packages? Packages is a list of commands. The one that you did that day for survival is using this. So whatever you want, you just click install. Whatever you want, you can just click and install. So everything is there. Okay, so everything is there. But it sucks, man. Why? You don't even know what the hell it means. Okay, now you are a beginner. Then you say, oh, what am I supposed to use? Am I supposed to use crayon? What is crayon? Colored terminals output. So on and so forth. So there's a lot of things that is not really user friendly. Okay, not really user friendly. Okay, so then we have the help commands. So you can get all the help commands here. Okay. If you ask the R people, they say R is very easy. And they say that there is a lot of support. You don't know anything, you can just post your whatever command that you type. Automatically, other people help you to do everything that you need. Okay. Depends on you how long you're willing to wait for the help to come lah. Okay, I do not know, but personally on my part, I find that SPSS is much more user friendly. Okay, so this is the viewer. We have not seen anything because we have not run anything yet. Okay. Okay, so you already see there, this is the R data that's already saved. Okay, so let's run the some of the simple analysis because we already imported the data set. Okay, so we're going to open up Ayub's notes. Okay, Ayub's notes is S1, Introduction to Biostatistics and Descriptive Statistics. Can see or not?
Boleh, Prof.
Alright, terima kasih. Alright. Okay, so these are the data set discussion. I'm not going to cover all this. This one we have covered many times already under SEM 1. Okay, so we're not going to cover this. So we're not going to cover this. Okay, so this one all known already. Okay, so this one they cover about bar chart, pie chart. We're going to do this later on. Okay, so let's start with the analysis. So we're going to cover measures of central tendency, mean, mode, median, standard. Then we are going to cover on dispersion, standard deviation, and IQR. We're going to cover on histogram and box plot. So we're going to skip this one, this one, this one, this one, this one. Yes, yes, yes. Okay. Ayub's note is a bit different this time. He's jumping from theory and practical. Okay. So you already imported data from Excel. Am I right? Okay. So we're going to do the first analysis. Okay. Everything on your left side is the command. Okay. What I'm going to show you, if you are not sure about what to type, just copy and paste. Okay. Just copy and paste. I do not know which one you're using for browsing. I'm using the Acrobat Reader. So this one there's some problem because when they copy everything. There is no way for me to take bit by bit, but never mind. Okay, I'm not worried about this because I can type the command. Okay, so please take note. We are going to do the data set on. We're going to get a mean, SD, median, and IQR of each. Okay, there are two exercises here. One is typing the command step by step. Then, the other one is we're going to attach and detach the file. Okay, so let's follow me step by step. First command. Okay, when you type the command, I'm not sure whether you can see this or not. Bottom left side, bottom left side. There is no space, the command should continue. Okay, when you type the file, okay, so you just now when you're working with this environment, the name of the file is OS. The name of the file is OS. So you have to type the name of the file OS. Okay, then you put dollar sign. When you put the dollar sign, they will pull the variable. So the variable here is age. You cannot type directly. I tried this, to type directly. Sometimes it does not recognize. So you have to select the name of the variable. So when you type like this, they give you the value, mean, OSH. What is the mean? 40.57. Okay, that is how you get the results in R. Okay, so there is no command. There is no command up here. Okay, there is no command. Doctor, there is no statistic up there. Yes, there is no analysis. There is no statistic up there. You have to type in the command. Okay. Okay, let's try mode. Okay, you type in the mode. Again, you type OS, dollar sign, select age. Okay, once you're done, press enter. Okay, they just say mode cannot. They just say numeric. Means too many lah tu. Okay, median. Okay, OS, dollar sign, age. Okay, enter. 40. Then standard deviation, SD, OS, dollar sign, H, enter. So standard deviation is 5.35. Let's see whether you can do variance. Variance, OS, dollar sign, H, enter. 28. So 25, yeah, correct. Okay. So we can also get the IQR. Okay. So IQR, okay, OS, dollar sign, H. But of course, you know, IQR is useless. What is more important is the 25th centile and the 75th centile. Okay. Okay. When we run all that command, you can see here in history, all the command that you type is available there. All the command that you type is available up there under history. Okay. Quantile. Okay. OS, H. Okay, then we are supposed to use comma, then set the number, so 0.25, enter. Oh God, 37. Again, we run the same command, but 0.75, 0.5. Let's try 0.5 first. 40, same like the median. Then we run for 75. 44. Okay, so IQR is 44 minus 37. Oh, correct lah. It is 7. 44 minus 37 is 7. So IQR is 7. Okay, that is the first command. That is the first command. So let's try the next set of command. Next set of command, you attach the file. So why you attach the file? So that you don't have to type in the command one by one. So you can see here, you attach the file itself, then you get the values, then you detach the files. Okay, so it is the same command. The only difference is you attach the file first. So you attach the file. So which file you want to attach? You want to attach the file OS. You enter. So you can see here the command is successfully executed. You already attached the file. There is no error. Okay. So after this, when you type the command, no need to declare the name of the file already. So you can just get the mean of the age. Okay. You can get the median of the age. Okay. You can get the standard deviation of the age. You can get the variance of the age. Or you can get the IQR of the age. Or you can get the values itself, the quantile. So Quantile, quantile. Okay, no need to declare OSH. Instead, you just type in the H. Then which one you want? You want the 0.25. Enter. Oops, cannot. Oh, hee. Sorry, typo error. Okay, so you can get for 0.5. You can get it for 0.75. Okay, so that is in short the first command. Okay, I know it sucks because you have to type in the command. Even worse, this does not come out in a nice table that you can copy and paste. So for the script to work, you need to type in the command one by one. Okay, first you declare what is x. X is the OS, which variable age. Then you get the mean and value of everything from there. Okay, so let's do this. Okay, I did read the workshop. They say do not touch the R script until your student has become comfortable with R. Okay, where to get? File. Okay, new file, R script. File, new file, R script. You can save the file. Okay, what is the name of your file? Script 1. Save. Okay, so the name of the file is script 1. So first you're going to use X. Okay, we are going to declare the file. Which one file we're going to use? OS $H. Okay, so after that this command, everything that we type is based on this X. Since you already declared the X, so after that you just state the command one by one, mean of X, standard deviation of X, median of X, and so forth, and they will give you the value automatically because the X has already been declared. So no need for you to type in OS anymore. So we're going to type in the command what we did down there at the bottom. So down there at the bottom, okay, we're going to just compare the answers. So mean what? X. Okay, median X. Okay, then we have the standard deviation X, variance X. Okay, we have the quantile. Okay, quantile, Quantile. Okay, what? X. Which one? 0.25. Quantile x, comma 0.75. Okay. Then you have the last one, which is IQR x. Okay. So by having all this, since we already declare the OSH is x, okay. So when you run all these commands, they will immediately give all the answers. So how to run? You click the button run. So you can see the first line declare y is x, s is OSH. You get the mean is 40.57, median is 40, standard deviation is 5.3, variance 28, quantile 25% is 37, quantile 75% is 44, interquartile range is 7. Okay, so that is the command where you run this. Okay, we need to detach the OS. Sorry, I forgot to detach. Detach. Sorry, when I was running this command, I forgot. I'm supposed to detach the OS. Because when we did earlier, we attached the OS. After we finish, we were supposed to detach. My apologies. Okay, luckily we were working with the same data set, so there was no problem. Okay, so R, let's close this one. Okay, so we're going to start plotting. So we're going to start plotting. It's very simple. Plot is either histogram, pie chart, whatever. So we're going to plot some of the diagrams. Right now I'm understanding why those who attended this workshop on R find it tedious, because you have to type in the command line by line. So we're going to do histogram, we're going to do box plot. Okay, and we're going to do it step by step with all these different commands. Okay, select tool, copy. Okay, let's have a look at R. Okay, what are we trying to do? We're going to get the histogram of H. It's going to come out here under plot. So when you type the word enter, the histogram come out. The histogram come out. So this is the histogram. Okay. For the box plot, okay, type OS, declare H. You get the plot. What plot is this? This is a scatter plot. Doctor, tak ikut kosong. Yeah, I know. Never mind. You all figure out how to change. Okay. OS $H. Okay, this is your box plot. But not so nice, eh? Why not so nice? Don't have labels. Okay, so you want to have the label for the title. You have to type in the command. Okay. This is where I don't like. Okay. This is where I Don't like. Why? You have to type in the command. Everything must use command. Okay. What do you want? I want the histogram of what? Or SH. Okay. You want to have the frequency on the left side. Just take note, this one, they have the frequency on the left side. Main title, histogram of age. Okay, so instead of histogram of OSH, we're going to get histogram of age. Then the XLab. XLab means label of X. Instead of having OSH, I'm going to have age in years. Yes. Ha ha ha. Then. See? So that is the difference now. You have the title. You have the age in years. Doktor, kenapa tak ada isi dekat dalam ni? Okay, you have to edit. Okay, you have to edit the command further. Let's go next one. Next command. What happened when you set the frequency as false? Okay, when you set the frequency as false, you get something else. Instead of getting the frequency, you get the density. So I'm going to recycle the command. To recycle, you just push the arrow up. Enter. See? Instead of getting the frequency, now you get the density. Doktor, lagi tak faham. Yeah. Same here. I also cannot understand why we use density. Anything and everything that you created here can be exported. And the format of export can be as an image file or as a PDF file. And or you can also just copy to the clipboard. Okay. Copy plot. Go to your software. Example, I'm going to show it on the PowerPoint. Okay, I'm going to show it on PowerPoint. Okay, so okay, this is the PowerPoint. These are all the different plots. Now I'm going to copy and paste here inside the slide. Okay, paste. So you can see here, you can, although you may not like the output that come out, ugly like hell, you can still copy and paste it into the. So now I understand why the diagram inside all the published articles look so horrible. They were using R. Horrible. Okay. Explain. Okay, so next one. Let's go back. Okay. So we already shown you how to generate the appropriate title and labels for the axis. Okay, now let's start with the categorical data. So for categorical data, we have gender. We have gender. Okay. Okay, so gender we have, you can see here, we have boys and girls. We have the boys and the girls, and the boys are coded as 1, girls are coded as 2. So if you run the command table OS gender, they come up with the cross tabulation table. Ridiculous, kan? How many boys? 48. How many girls? 52. Horrible. Make you miss SPSS even more. Okay. Doctor, we want in percentage, kan? Instead of type table, you put proportionate table. Enter. Now you get percentage, 48% and 52%. Horrible. Even getting more horrible. Can we get it nicer? Okay, let's get it nicer. Let's have a bar plot. Okay, a bar plot of the again. It's horrible. Why horrible? They put 1 and 2. What's the label? Male and female. Don't have the label. So you want to have the label, what happened? You have to create a new variable. You have to create a new variable. So you have to declare instead of 1 and 2, you have to put male and female. Okay, jom, let's start. So to do that, we have to create a new variable OS gender 2. And this OS gender 2 is derived from OS gender 1. So OS gender 1, and we come up with the labels. Okay, so I'm going to show you afterwards. Just finish this exercise about having the pie chart, so that we got something to compare against. Hello, my screen doesn't work. Okay. What happened is my toolbar is refusing to come down. Okay, so now we have the pie chart. Okay, so the pie chart again, this is male, this is female. We have more female than male, but the label is horrible. Let's find something nicer. Let us create the label. Okay. To create the label, you have to create a new variable. And when you create the new variable, you have to get the label from the another, sorry. To create the labels, you have to create a new variable, and the new variable will incorporate in the label. So how to do that? Okay, I know you cannot see this yet. Remember the x and the x1. So now we create a new variable. What is the new variable? OS gender 2. OS, why? Because we are asking it to go into the table, the data set OS. We create a new variable, gender 2. So where you get this OS gender 2? It is recoded from OS gender, okay, So it comes from which variable? Factor OS gender. So we declare that inside there got levels of 1 and 2. C is for categorical. So then we have again labels. Categorical, 1 is male, the 2 is female. Okay, so we have the levels. Level is 1 and 2. The label for the levels is 1 is male, 2 is female. So when you type this, you press enter, a new variable is created, which shows the gender to female, male, female, male, female, male. So what happens now, when you run this code, you are creating a new variable. You are creating a new variable, and the new variable is gender 2, and they have all these things coded as female and male. Okay, so you can see that now it is changed from numbers, numeric, to become C category. From numbers to become category. Okay, so you can see why R is different than SPSS. Okay, so enough about slagging the software R. Okay, now let's run and see whether everything becomes hunky-dory after we create the new variable. So I'm going to run the command here. Click the arrow up. Okay, we're going to start the first one. Remember, we already created new variable OS gender 2. So now I'm entering the OS gender 2. Now you get male how many? 48, female 42. Okay, so remember we had this command proportion table. Male, female 0.48, 0.52. Again, we run the same analysis for bar plot. Instead of getting for gender, now we have the gender 2. You can see on the table on the right side, now you have male and female. Still sucks, no frequency here. Let's see the pie chart. So we have the pie chart, OS gender 2. Enter. Now we got male and female. Still no figures there. Okay. So I'm just trying to show you everything is possible like SPSS, but you have to work harder. You have to work harder. So I'm just going to save again. Okay. Okay. So as you can see is now, if you add the label as such, you get a much nicer output because you already declare the label of each one of them. Okay. So here, okay. I'm sorry, this thing is not displaying correctly. Somehow my taskbar is not completing. Okay. Again, we get the bar plot for table OS gender 2. The main title is distribution of gender. You can play around with it. The label for the x-axis is gender. You press enter, you get distribution of gender, male and female. You get gender. Same for the pie chart. I just type the word. Just go up, just type the word pi there. Okay, you get distribution of gender, male, female, gender, but still no percentage. Okay. Okay. If you don't like the idea of typing the word OS gender every time, so you notice that we keep typing the word table, OS to gender, so on and so forth, you can just declare what is X and then you run the analysis as such. Okay. Okay, so let's go and under the script file, new file, R script. Okay. Okay, so we're going to save this one. File, save. Script 2. Okay, so this whole line run. Okay, automatically they run. Okay, basically you're saying that you declare what is X. X is table for OS gender 2. Then you get the proportionate table of X. Then you get the bar plot of X. Then you get the pie plot of X, and they all are here. Inside. Okay, so that is the exercise that Ayub wants you to do. Okay, this one was not necessary. This one they just come out. They declare what is X. Okay. Okay, so this one the data set that I mentioned to you just now. Okay. 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 Let's go next one. So we already finished with the part 1 of the lecture. Okay, so next one is inferential statistics. This is where the t-test whatnot comes in. Okay, this one we're not going to cover. We already covered this earlier. What is inferential statistics, types of inferential statistics. Okay, this one is about CI, confidence interval. Confidence interval is very much dependent on standard error. Okay, standard error is the, if you look back the formula of standard error, standard deviation divided by square root of n. Okay, standard error is the standard deviation divided by the square root of n. Okay, so they explain what is the meaning of standard error here. So if you have to get the mean of 16.14, then you have a standard error of 0.426. Then you are 95% sure that the mean duration of exercise of the population will be between 15.3 and 16.98. Okay. Okay, so let's get the mean of the exercise time. Okay, okay, so I'm going to press this button escape. I'm going to select tool, mean, copy. Paste. Okay, so what is the mean of the exercise time? So you can see here for exercise time. Okay, so the mean for exercise time is 16.14. The mean for exercise time is 16.14. Okay, so now I'm going to minimize the screen. I'm going to go back and get that command. If we get the t-test and we ask for the confidence interval, we get the value. Okay, so this is this. Okay, please note we are asking for the t-test, OS, name of the file, exercise time, the name of the variable, then the dollar sign is for the confidence interval. We get the confidence interval of 15.29 and 16.98. So we already shown you on how to run the analysis for the ni. You nampak the whole point here to get the confidence interval. Okay. But this one they just give you the CI. This one they just give you the CI. Okay. Okay. Next. Okay. Next one is the CI for proportion. If you get the rate, what is the CI? To calculate the confidence interval for proportion, we need to know the standard error. In this slide, the standard error is written as 0.05. So how did we get 0.05? Is it from this formula? No. That formula is for mean, variance, and standard deviation, not for standard error. For standard error, the formula looks like this. Standard error is equals to square root of proportion P times proportion Q divided by N. So here, it is shown how we get the value of standard error, which is 0.048, which is almost similar to 0.05. Using that standard error value of 0.05, upon calculation, the value of the confidence interval for proportion of 0.37 is equals to 0.27 and 0.47. Dia kata proportionate test sum obesity equals to 1, length obesity. Okay. Okay, padahlah. Okay, thank you. Nasib baik ada pakar ni. Ihsan, kau pun dah pandai punya?
Tak ada. Tak pun. Okay.
Tahniah. Okay, when we run this analysis, we get the one sample proportion test with quantitative correction. Okay, and we get the value. The proportion is 0.37. The selang keyakinan adalah 0.27 hingga 0.47. So we are 95% sure that the prevalence of obesity is 37%. And the lowest value is 27.7. The highest value 47.3. Okay. So now we are going to run this one as a binomial test. Okay, we are going to run it. So when we run as a binomial test, you can see there the number of success is 37, number of trials is 100. Okay, the p-value is. So this one is the same like the binomial test we did in the first semester. Alright, next. Yeah.
Kau tengok dalam Teams.
Ada. Okay, so ni binomial test. Binomial test, sum OS obesity equivalent to 1. Length OS obesity. So this is the exact binomial test. So ini macam kita buat dalam binomial test. How many trials? Berapa banyak percubaan? 100. Berapa banyak kejayaan? 37. Gagal 100 tolak 37. Iaitu 63. Maka p-value adalah 0.1203. Maka ianya adalah significant. Okay, so this is the binomial test. So next. Okay, how many percentage of population has age above 40? Okay, so kita boleh juga gunakan untuk command numerical untuk proportionate. Okay, so bila kita run proportionate test untuk umur lebih daripada 40, adakah ianya kurang atau lebih dari 50%? Kita type, paste. Okay. Okay, so dapat nilainya adalah 48%. Dan 48% tu adalah selangkah kenanya 0.379 dengan 0.581. Nampak ianya termasuk nilai 0.5, maka p-value-nya adalah 0.7642. Okey. Adakah kita sempat habis? Tak. Sebab ada lagi separuh lagi slide. Okey. Ini tak ada apa, just compare. Please take note our aim here is just to see how to apply R dalam test. Okay. So ini adalah independent t-test. Kita nak buat t-test antara exercise time lawan dengan obesity. Kita ada code obesity 1 and 2. Satu yang obese, dua yang tak obese. Exercise time adalah dalam jumlah masa sebenar. So kita run this analysis. Kita anggap dia punya variance adalah equal. Ini sama cerita macam Starta semalam, last week. So kita type kat sini, paste. Okay, kita ada t-test, OS exercise time lawan dengan OS obesity. Kita anggap variance sebagai equal. Tekan enter. Kita dapati bahawa kita ada dua grup. Satu grup exercise masanya 16 jam. Satu lagi grup ada 15 jam. Perbezaan tak banyak, hanyalah satu. Okay. Not even satu. Sini tulis very little. Jadi T adalah 1.0623. P value 0.2907. So orang gemuk dengan orang kurus sama je exercise. Orang gemuk ni lagi banyak exercise yang kurus. Sebab orang gemuk tak nak, dia nak kurus kan. Tapi dia exercise macam mana pun tetap tak kurus. So this is how they explain. The mean duration of exercise are not significantly different. P value is not significant, 0.291. Okay, 0.291. Hypothesis test. Okay, tak ada apalah, tak ada apa. Ini p value, so we have p value pakai 0 less than 0.05. Okay, same. Alright, how to present p value? Always present exact p value up to 3 decimals. Okay. Okay, in math 0.020 is the same as 0.02, but we should put a 0.020. Alright. Never present 0.000 as 0. This one saya selalu cakap, tapi kau buat juga. That day during your project, you all still presented as p equals 0.00. Rasa sekeh budak tu. Okay. Okay, is our test one-sided or two-sided? Kita selalu pakai two-sided. Because we're not testing that they are less or more, we are testing they are not equal. So, okay, they are not equal. Could be more or could be less. Alright, this one I already explained many times. Okay, dah sudah. Okay. Yay! Okay, t-test, we're comparing the mean. Okay. We're saying that the mean are equal. We look at dispersion. I think I'm among the few lecturers that present this inside their slides. I put it inside my slides for SPSS. 11 test for okay, nak tak nak kita akan run 11 test punya package. Okay, jom kita install packages car. Somebody nak minta library, jom kita ambil library. Okay, so let's install the library. The library file is install packages car. You can type the command directly like this. Okay, you go, or you can just select kat di sini dan select dan install. So you can see here. Okay, tak nampak alright. Apa kita buat kat sini, left side, paste, enter. Woo! Jek. Okay, so all these things has been downloaded. Okay, nampak ni, car ada, yay, dah ada. So we can load the required library, which is car. Oh, dia kata required. Okay. Okay, so next, library car dah masuk. So Syahida, your request for library dah jalan. So now we're going to run this test. Adakah exercise time equal variance or not equal variance? If you check my video for the starter, I explain how to do it manually. Okay, so we're doing the Levens test. Okay, so we are comparing the exercise time compared with the category of obesity. Adakah variance equal atau berbeza? Yes, my result not the same like this, but still it is not significant. Okay, and when we run the t-test, they are not significantly different. This one we already run already. We run the independent sample t-test for this earlier. We already proven that there is no difference. The p-value is not significant. The p-value is 0.2907. So there is no difference in exercise time between obese and dengan not obese. Okay, so what is how to report? Duration of exercise between the two groups were not significantly different. P is 0.291. There is no significant association between duration of exercise and obesity. So it does not matter how often you exercise, you still end up with obesity. So dia kata run to get the standard deviation. To get the standard deviation for this, you have to type this command. You can get each one, you can get separate. This one is for combine. So when you run combine to get standard deviation, paste, you get 4.8, 3.88. So for obese, the standard deviation is 4.8. The not obese, the standard deviation is 3.88. Alright, and with that we finish the lecture for what to report. The CI of mean difference is 0.8. and 2.7. Okay, so therefore the difference, the mean difference is 0.9, you get 0. Minus 0.8 is 2.7. Kat mana dapat ni? Kat sini. So you can see here 0.8, 2.687 so the 95% CI include the value of 0. So when you include the value of 0, therefore it is not significant. In case the sample size is less than 30 in one group, so we need to check for normality assumption. So you can do the t-test for both. Okay, t-apply. So you need to take note of the command t-apply. You get separate output for the histogram for exercise time obesity. You just type like this, paste, enter. So you got the histogram for x equals to 1, and we get the histogram for x equal to 2. Alright, so this is 1, this is the other one. Okay, so this is 1. Okay, and with that we finish. We have proven that the table, that the data set is normally distributed. Okay, let's look. Okay, I think this is the last slide. Okay. Okay.